So moving on. What we're talking about now is we defined the total effect in our last problem. Okay. And now we want to, and the term we're going to use is we want to decompose the total effect into a price effect, which we're going to call substitution of pure substitution effect, and an income effect. Now, okay, so I want to talk to somebody, and you're pretty loud and clear this morning, Sonica, so I'll talk to you. Are you still there?
Yeah.
You're like, you sound so enthusiastic. Like, are you really want to talk to me? Yeah, Sonica, I do. Okay, so I just want to be clear about this. Okay, just language-wise. Okay, the total effect of a price change on the consumption of X. Okay, so like we saw before in our example, right? So that means, and we're going to define that as dx is equal to some amount, we called it x1, after a price change you were consuming of X, and the difference between that and what you were originally consuming at some other different price, right?
Yeah.
You follow me, Seneca?
Yes.
So like in our example, X0 we said was the initial level of taco consumption at the price at PX is equal to 13.
Mm-hmm.
And then we went to X1, which I don't remember what it was, but it's like 18.04 tacos at new price PX of 4, right? That was our example. And so then that's going to imply that our dx, if we calculate it properly, right, is going to be, we said, equal to 18.04 minus 5.55. So we said that was 12.49. Okay. Now, if I was to illustrate that on a diagram of the consumer's utility function in the form of indifference curves and budget constraint, it would look like this. And let me try to do that quickly. So, and there are pictures like this in your book. And let's do, we'll do initially, in fact, remember the price of X was high, right? And then it dropped to 4, right? And so then we'll do like this lighter color green. And so it's going to look like that. Okay. And I'm not going to put specific numbers on here, but I'm going to note that the horizontal intercepts are the income And maybe I'll do this in a different color. So the income of the consumer divided by P, I'll call it X0, which is the initial price.
Yeah.
And that's going to be that point right there.
Yeah.
Okay. And actually, I'm going to delete that. Again, change the color so we're a little bit clearer. So that's the horizontal intercept for the initial budget constraint.
Mm-hmm.
And then you also know that obviously we're graphing y on the y-axis and x on the x-axis, and the intercept for the vertical axis is I divided by py. So that's that point right there, and that's not changing during our analysis. And then the other point over here on the new budget constraint, I'll say it's I divided by P X1 is here. Okay.
Mm-hmm.
And so, and let me try to do a good job here. I'm going to do the consumer's initial indifference curve. And okay.
Mm-hmm.
And their initial optimal consumption bundle is, oh, delete that. Is right there. That's the point of tendency. I made it really big, but it's okay.
Yeah.
And then with the new budget constraint, and I'm just going to draw it arbitrarily.
Mm-hmm.
So there's this new consumption bundle.
Yeah.
And there's going to be a new indifference curve.
Mm-hmm.
And it's going to be like that. Okay.
Yeah.
You like my picture?
Yes.
Okay. Well, you should, because this is a picture you guys are actually going to most likely have to draw on exam day. So
Mm-hmm.
now the amount of x1 is there and x0 is there. Okay.
Mm-hmm.
And so I don't think I need to put x0 and x1 on the axes, right? You can see where they are.
Yeah.
Okay. And the total change is this distance here.
Mm-hmm.
Okay, between those two lines. That's how X is changing in response to the decrease in the price. Now, I also want to point out, depending on who you are and which version of Ignithium you get, that sometimes there's a price increase and sometimes there's a price decrease on Ignithium. So if it was instead of a price decrease, it was a price increase, then it would be the exact same thing, but X0 and X1 would be flipped, right? So that's important to point out. You could have a price increase or a price decrease, and you have to interpret the diagram properly. Now, the decomposition is like the following. What we're trying to do, or what we're trying to accomplish, is we're trying to say and I just want to draw a straight line here. There's some amount of X, and I'm just gonna do it like this. Okay. And I am also going to then erase this and erase this. And I do this in class too. I erase stuff because I don't want the diagram to get too cluttered, because otherwise people won't be able to see, like, right?
Yeah.
So there's some amount of X, right?
Mm-hmm.
And I usually call it, and I think in the Ignithium exercise too, it's called XS. And we use XS to isolate the substitution effect. So how is it that we do that? Well, I'm going to illustrate for you. Okay. And so you see the new budget line is this bright green budget line here, right?
Yeah.
So to isolate the substitution effect, and it's important that I do this, so I'm going to have to label the indifference curves. Okay. And U0 will be our initial level of utility.
Mm-hmm.
And our new level of utility, I'm going to label that U1.
Yeah.
Okay. So it has to be the new budget and the original level of utility. Whether it's a price increase or a price decrease doesn't matter. What matters is the original level of utility and the new budget. Okay. So maybe I should write that on the side someplace, because it's, like I said, super important. So to isolate the substitution effect, and I'll say use the original utility level. And by original utility level, I mean utility level associated with the optimal consumption bundle at the initial price.
And where would that be on the
Well, I'm going to show you. I'm going to show you. Hold on a minute. Okay. The original level of utility and the new budget. Okay. So, let me find out. So go ahead and ask your question, Sonika. So
I was asking, where would that level or that point be based on the optimal consumption bundle?
well, okay, I'm gonna draw a little. So original level of utility is there. Can you see my little purple arrow? And that's the level of utility associated with this optimal consumption bundle. Can you still see the purple arrow? Because I'm still drawing it, but this is helpful for me. And then remember, that's the level of utility associated. This is 1 point on the orange indifference curve. So all of the consumption bundles on this orange indifference curve, can you see as I'm tracing it out with the purple arrow, have the same level of utility, which is U0. Does that make sense?
Yeah.
Okay.
So essentially where those 2 points hit, where those 2 lines hit at a tangent is that optimal consumption. I mean, optimal
Yeah.
utility.
So the optimal consumption bundle is defined by this. Remember, we have the tangency condition that we just went over?
Yeah.
Yeah, that's the tangency condition right there. Tangency between the budget line
And the
and the indifference curve.
okay.
So yeah, that tangency between that's why I said originally, and I don't know how much you paid attention to the other lectures or not, but I said it's a lot like the equilibrium point in demand and supply. It's where two, and one is nonlinear and the other one is linear. It's where the two curves touch, just like how the point of intersection between supply and demand is where two curves touch, right? The only difference is in demand and supply, they touch at one point, which is an intersection. Here, it's one point, which is a tangency. Does that make
Yeah.
sense?
Mm-hmm.
So now back to XS. So now I want to point out that I could take this new budget constraint and find a point of tangency between it and the original indifference curve.
Yeah.
Okay. That would identify XS for us. Okay. And we'll talk more about that in a minute. So I'm going to leave this, but I did that so you could see what I'm trying to do is a parallel shift of, let's see if I can, it won't let me. Okay.
Mm-hmm.
So, okay. And I'm not even going to draw it constrained to the first quadrant. I'm just going to draw it all the way out here. Implicitly, it is constrained, but I just want you guys to be able to see
Mm-hmm.
that it is supposed to be a parallel shift of the new budget to the original indifference curve. And then there'll be some point there, and that point of intersection well, actually, or point of tangency, excuse me. That's actually going to define where our excess is. So in this case, I was just approximating with this line now. I'm going to move it there. Okay. So in terms of illustrating what's happening, this is again the diagram that often I ask students to draw, and I'm going to kind of move. Well, actually, what I'm going to do is I'm going to do what I did here and move these lines all the way up, just so we can see maybe a little more clearly the distances that we're talking about. But you see how the diagram gets cluttered?
Yeah.
It's like, wow, there's so much going on in this diagram.
Mm-hmm.
So I'm going to pull this stuff all the way up here and try to be a little bit more explicit. Okay. I think that'll work. The reason I did that is because I want you guys to always be able to pay attention to this total distance.
Yeah.
And then, so I want to have the yellow arrow here. That's the total distance, right? And then this part of the distance between x0 and xs, this is called the substitution effect.
Yeah.
And I want to be clear that the way, and depending upon your diagram, again, this could be flipped if it's a price decrease instead of a price increase. But what you'll notice is that you're going to have one indifference curve that has 2 points on it.
Yeah.
And whatever indifference curve has 2 points on it, the distance in the x dimension between those two consumption bundles here and here, that's the substitution effect.
Yeah.
And then the remaining distance, and I don't know what color to do it in, but we'll just do it in red. The remaining distance is the income effect. So I'll say, I'll do a little legend over here. Equals sub effect and we'll do this one is equals income effect. Okay. And so notice that the orange distance plus the red distance equals the yellow distance, right?
Yeah.
So that the substitution effect and the income effect equal the total effect. And actually, I guess I should be just a little bit more clear about one thing on this diagram. And that is that excess is right there. Okay. Okay. So does that make sense, Sonica?
Yeah.
And Derek, are you following along? Are you good?
Yeah. Yep.
Okay. So now I just want to talk a little bit about what do we mean by the substitution income effect. Okay. And this is a little subtle. There's some nuance to it. But the substitution effect, what is it? Is the change in the consumption of X due to a change in the price of X holding, and I'm going to put this in parentheses. It's important, but this is sort of the subtlety, holding real income constant. And let's see. Yeah. So that's fine. And the big result in microeconomic theory, the one that is and there are a couple different ways to say it, but the simplest way is rational economic decision makers will, now this is supposed to be super strong, always exhibit negative substitution effects. And the reason why, and I'm not so sure if you get the kind of this is like the microeconomists. So do you remember? Did you ever see, Derek, any of the footage of the moon landings?
I'm pretty sure I have at some point. Yeah.
Yeah, like they go up there and they step out of the capsule, and then pretty soon they go over and they throw the flag in the ground, and they're like,
Yeah.
we're here, right?
Yeah.
This is as strong a statement as you can make in science. This is like our universal law of gravitation. It's no longer the law of demand and the law of supply, even though we still teach that in principles. Where economists, put their flag in the ground is, if you're a rational economic agent, you're always going to have negative substitution effects. Doesn't really fit nicely on a postcard, right? But this is the one and only prediction of microeconomic theory. It's not demand curve slope downward. It's not supply curve slope upward. It's negative substitution effects. That's it. So that's why it's really important, because remember, we said before that there are some strange phenomena that economists and other people have observed, like upward sloping demand curves. And we can use income and substitution effects to explain upward sloping demand curves. But the real risk is our theory starts to sound pretty weak if we say, well, yeah, like really what economics says is anything goes. Upward sloping, demand curves, downward sloping supply curves, whatever, right? So the theory has to have, some solid prediction, which means that it's falsifiable, that somebody could come in and say, hey, you know what, you guys, your theory's junk. You've got a prediction and it doesn't match reality. Our data conflicts, from our experiment, and this theory is just bogus. So every scientific theory has to have, absolute predictions, because it has to be able to be falsified to be part of the scientific method. The way it works in the scientific method is you make a prediction, you do an experiment, and if your data conflicts with your prediction, then your prediction is wrong. And you have to modify your hypothesis or your theory to come up with a prediction that matches the reality. That's the game. And it's no longer the case that with economics we insist there always be downward sloping demand curves. But the one thing that we do insist on is that substitution effects are always negative. So it's important that we understand the substitution effect, and some of the wording in Ignithium, plays on this subtlety. So I want to go ahead and kind of drive this home. A negative substitution effect means that if we calculate dx, that's the change in x, and take it over dp, which is the change in price, that this will always be some number that's less than 0. Okay. And I should be careful here that the dx in this case is the dx with respect to the substitution effect only. It's not the total effect. So to be more explicit about this calculation, our dx is xs minus x0, that difference divided by px1 minus px0. So it's the substitution effect in terms of the change in the quantity. On this diagram, it's the orange distance between x0 and xs. It's that change that we're calculating. Does that make sense, Derek?
Yes.
So yeah, our theory says this number is always less than 0. Okay, so it's negative. And yeah, I think that on Ignithium question number 20, they say, what is the impact of the price change due to the substitution effect or whatever? And they're just asking for you to calculate dxs, which is the xs minus the x0. Okay. They're not asking you to calculate the ratio of the substitution effect divided by the price change type thing. So, but anyway, this is what it means for the substitution effect to be negative. They're talking about this ratio. Now, I also want to say that the income effect is the change in the consumption of X due to a change in the consumer's income holding prices constant. Okay. And you'll note that income effects can be positive or negative. And hopefully at this point in time, you all know that a positive income effect is what we call a normal good, and a negative income effect is an inferior good. That's how we define normal and inferior goods. But to be clear, again, when we say that income effects can be either positive or negative, what we're talking about is, so this means that, again, we're talking about another ratio. If we calculate the income effect portion, which is going to be now this is a little bit, I'll call it dxi for the income effect, and I'll be more explicit over di, which is the change in income. So hopefully you guys can see that. So this dxi part is going to be x1 minus xs. So it's going to be the red distance that we talked about, divided by the change in income. And this is kind of, I'm just going to leave that as d real income, because it's nothing you guys will ever be asked to calculate. I'll explain in a minute what we're talking about, but this number, if you did calculate it, it could be greater than or less than or equal to 0. Okay, so do you follow me, Derek? Are you good? Sonica, are you there?
Yeah.
Okay, do you follow me?
Yeah.
Okay, so the deal is this. So remember, we said that, and I'll draw this on another diagram really quickly, and then hopefully the connection will come in, right? If we take a look at the consumer's budget constraint, and I'll just draw a general budget constraint here. Okay. Are you with me, Sonica?
Yeah.
Yeah. Okay. So if I hold prices constant and just change the income, remember that these intercepts are, this is I divided by PY, and down here, right, it's income divided by PX, right? So if I, defining the vertical and the horizontal intercepts, right, Sonica?
Yeah.
Are you with, right? So if I just change I holding price of X and price of Y constant, it's just going to cause a parallel shift either inward if my income goes down, or outward if my income goes up, right? And this income, I want to point out, is nominal income. Do you know what I mean by nominal income?
I know what a nominal good is. So I'm assuming.
So nominal income in this case is a dollar amount, like $195. Real income
is more of like it's adjusted to inflation, basically.
Well,
So
a way of saying it measures purchasing power.
Yeah.
Right.
It also
it's
looks
like
at
what you can actually buy with your nominal income, right? So the big subtlety here is, notice, remember, and I'll say we'll use orange for this. We had this concept before that we talked about, which was the consumer's affordable set. Do you remember that?
Yeah.
And in this case, right, and I don't know if you can see my orange arrow. Can you see it? So the affordable set is everything on the consumer's budget line, and then everything below it too. Can you see me moving the arrow around to all these points?
Yeah.
Right, all of that's affordable. Now, notice if I decrease the consumer's nominal income, right, the affordable set shrinks. Now it's just these points down here. You see what I mean? So when you're holding prices constant, like we're doing in this example, the nominal and the real income relate to each other in the way that you would expect them to. If you increase nominal income, and I'll give an example way out here, right? So now I'll do this big budget line here, right? Then the affordable set, the purchasing power, right? The purchasing options of the consumer are going to expand, right?
Yeah.
Now you can purchase all of these units here, all of these different consumption bundles. And so the purchasing power is really a measure of this affordable set concept. And then if I decrease nominal income, I'm going to shrink the affordable set. Okay. So maybe I should write that here. If prices are constant, then purchasing power and nominal income are directly associated
Yeah.
with each other. So when you were talking about inflation, and it's, it makes sense. Inflation has to do with the prices changing, right? And so another way that we could get this affordable set to shrink or expand would be by changing the prices, because that's going to cause changes in the affordable set too, right? I mean, if we have all of the prices increase holding the nominal income constant, if they, increase at the same rate, we're going to get the same thing, this like parallel shift inward of our budget line, right?
Mm-hmm.
So now let's go back to our diagram. So now we're actually talking about a price decrease. And so let's illustrate what happens when just one price changes, right? So here, right, we had this original lower price of X, and then we had this affordable set here.
Yeah.
Right? And then the price of X decreased and our affordable set expanded. So really, as we move from the dark green budget to the light green budget, there is an increase in real income, even though we're not changing nominal income, but we're doing kind of like what you said, we're increasing the purchasing power by changing the price of one of the goods, right? So we are changing the consumer's real income. In fact, you can see, since we have an expansion of the affordable set, we're increasing the consumer's real income. So back to our diagram here, what we're really saying is the income effect here is isolating this expansion effect of the price decrease. And so this is kind of like the weird part for a lot of people. Since we do this decomposition by doing this parallel shift of the budget from the new budget, and really this is a fictional budget constraint, but this fictional budget constraint that represents a decrease in both nominal and real income, holding the prices of the two goods constant. Because notice, right, remember the prices are represented by the slope of the budget. So what we're able to do is actually take this price change, right, and see what part of it is due to just the real purchasing power, and what part is due to just the price change by itself. So that's the exercise that's going on here, is we're erasing the impact of increasing the purchasing power of the consumer by lowering the price of X by constructing this fictional budget constraint that holds the consumer to the same level of utility. So the main point is that when we say that the income effect is the impact on the consumer's purchases holding prices constant, what we really mean is holding real income constant.
Mm-hmm.
And we're actually using utility of the consumer at their original utility level to determine what their real income is. And that's where things get a little bit weird, because you know, now we're talking about real income, but we're using utility. And the reason for that's kind of a little bit complicated, but I'll just say it quickly. I'm not sure it's going to sink in right away. But remember, when you're talking about the purchasing power of the consumer, one way of measuring purchasing power is just based on the size of the affordable set. But another concept that's really closely related has to do with the standard of living the consumer's experiencing. And if you think about this in the context of like macroeconomics, they're always talking about the real standard of living and like GDP per person. And what they're really trying to get at is that, you know, it's one thing to say that you've expanded the consumer's affordable set, and that's what we did here as we lower the price from the dark green to the light green line, right? There are more consumption bundles available. But one of the issues is, what if you've lowered the price of something that nobody wants, right?
Yeah.
You know, an absurd example would be, you know, I don't know if there's anything that you buy that you like kind of buy because you need it, but you don't really, you know, care about it, or like very much of it. Like I'll give you, you know, what's my example
Mm-hmm.
is the Disney Channel. You know why? Because I never watched the Disney Channel. The only person in my house that watches the Disney Channel on a regular basis is my 13-year-old, right?
Yeah.
So if they decrease the price of the Disney Channel, like, so what? I mean, I would obviously save a little bit of money, but it's not really going to affect me very much because it's not something that I, you know, based on my preferences, would purchase a lot of.
Yeah.
But if they decrease the price of my favorite beer,
Mm-hmm.
right? Well, then, you know, I'm a lot more excited, right? My standard of living is higher because you've changed the price of a good that I really care about. And that's the reason why we end up associating real income with your level of utility. So the main point is that we're holding your real income constant when we take this parallel shift of the budget. I'm trying to be careful to make it parallel now. And isolate a point on the original indifference curve, your original level of utility. And then I'm holding your real income constant and able to properly isolate the substitution effect. And actually, I said this wrong. because I wanted to emphasize this real income up here. What I want to do here is let me correct my statement. Yeah. Okay. So this is right, but I'm trying to explain this part of the statement right here, that these 2 points are holding real income constant, and the ones between the purple and the second indifference curve, that's letting your income expand, holding prices constant. Okay. So anyway, I've done the explanation for the income and substitution effect decomposition. I've showed you guys the graph. I've explained what the income and substitution effect are. You can go ahead and look up the definitions again in your book, but we have one thing left to do, and actually it's the last 2 problems on your Ignition problem set that you guys probably can't quite solve yet. So I think I'll make the homework due next Thursday, and then we'll work on those last 2 problems next Tuesday.
Okay.
Just so we can go over, because I don't think you guys will be able to, based on this lecture alone, we didn't get quite far enough to be able to for you guys to solve those, unless you pay really close attention. So we'll work on those last 2 problems, but you should be able to do everything but problems 19 and 20 now, and then we'll work on 19 and 20 later. So any quick questions, because we're a little bit over time? Oh, okay. All right. I will see you all soon.
Bye, Professor. Thank you.
You're welcome. Bye.